This is lecture 25 of the Quadrant Model, Mathematics. Euclid's Elements was the most popular book behind the Bible. Euclid's Elements had 5 postulates. The 5 postulates are the most famous set of postulates in math history. The 5th postulate was proven to be false. The 5th is always questionable. However, the discovery that the 5th postulate was false led to the uncovering of different geometries. Ancients saw the 4th postulate as different. Proclus did not think that the 4th postulate should be a postulate. The 4th is always different. Euclid also proposed 5 axioms. The 5th axiom is false and the 4th is different. Some suggest that Euclid intentionally made the 5th postulate false so that out of its discovery as false, new geometries would be discovered. I learned about Euclid's postulates on a teaching company course on mathematics, and the professor described how the 5th was incorrect and the 4th was different. So the postulates are: to draw a straight line from any point to any point. That's postulate 1. Postulate 2, to produce a finite straight line continuously in a straight line. Postulate 3, to describe a circle with any center and distance. Postulate also, the 3rd is about circles. A circle has the look of being an object and being whole. The 1st postulate is about a line. A line is like air, taking up no area. Air is the first square element. The 2nd postulate is a straight line that is extended. The 2nd element is water. Still, there is no area being taken up, but it is longer. The first 2 are a duality. The 3rd, the circle, brings area into the equation. The 3rd square is the most solid. The 4th postulate is on right angles. Right angles are quadrants. The 4th is always transcendent. Postulate 4, that all right angles are equal to one another. So semiotic squares take the form of a quadrant and are very popular. Semiotic squares are used a lot in academia. So Gramma's semiotic square. Dehaney describes how in cultures throughout the world, the first 3 numbers were always represented similarly, but the 4th differently. For instance, Roman numerals has 1, 2, 3, and 4 is written with a V, different from the first 3. There are some cultures that represent the first 4 numbers similarly, but all cultures represent 5 differently. Dehaney also points out that when tracking objects, only 4 can be tracked at one time. With 3 objects is difficult, but 4 very difficult. But 5 at one time is impossible. The quadrant model has 16 squares. Also, scientists pointed out that a person can only imagine 16 squares at one time. People can make flash judgments on the number of objects from 1 to 3 well. At 4 it becomes difficult, and at 5 the accuracy makes an exponential decline. 4th is always different, 5th is always ultra transcendent.